show you guys how to size all of the wires in this transformer. We're going to show you how to determine what size overcurrent protection you need. We're going to show you how to size the grounds, what size the main bonding jumper needs to be, what size the grounding electrode needs to be, for concrete encased electrode, if it's cold water, what size the bonding jumper needs to be, how many parallel sets you're going to need, what's the difference between primary and secondary conductors, whether or not you even need a bonding bushing. We're going to be doing all that stuff. So this is probably one of the most common costly mistakes that I see in the field. And really, it's not the journeyman messing it up. It's even the masters. It's all the way down. The journeymen are just doing what they're told. What's up, Sarush? What's going on? So if you can identify some of these yourself, you can potentially save yourself and your company time and money. Time is money. So that's what this is all about. Now, in this picture here, looks like your wire work. In this picture here, it's actually wrong. This was actually done incorrectly. So what we have here is two sets of 500, and then we have one set of 500 coming in. So I'm going to explain how that all works. We might wait for some people to get here. We'll probably wind up pulling out the code book and doing some other stuff, but in general, there's so many things to hit on when you're talking about transformers and how to size the wire and all that stuff. We got Sayer and Sarush so far. So take note of the wire color. We got brown, orange, and yellow. Brown here for H1. Orange would be H2. You're not going to be able to see it behind there, but there's going to be an H2. If I scroll up. Ah, there we go. There's an H2. And what's up, Jeremy? What's going on, Wireman? 25 months. Man, I appreciate that. Trying to like that comment or do something. Couldn't do anything with it. So there's H2, and then yellow is going to be H3. Now that's going to be our high voltage. And typically, this is the most common use of a transformer would be to take a high voltage, convert it to a low voltage, and pretty much 2 to 1 double your amperage is usually what ends up happening. So if we're going to put 200 amps in, we're going to get 400 amps out in general. In this case, they were putting 400 amps in. They're going for 800 amps out. And we're going to talk about how they screwed that up and what's really common to mess up here. Medium voltage is anything over 1,000. I think 1,000 is considered medium voltage. This is just standard low voltage and high voltage. 122.08 being low, and then high being 277/480 in this case. So then we got black, red, blue. So X1, black, X2, red, blue, X3. Now, there's going to be an XO down here somewhere. Let's see if we can find it. There it is there. XO is going to be the neutral. And your transformer creates your neutral. So you're going to notice they don't bring a neutral from the source here. And this is, I've talked about this multiple times about the current going backwards through the windings, back through the hot. This is a transformer. So is this a converter? It's a transformer. It converts high to low or low to high, depending on what you're doing. Or you can convert low to low and just change the voltage. Amps help you out. Yeah, exactly. Nothing helps insomnia like Whiteboard and Codebook live streams. There you go. It's more than meets the eyes. No pronouns for this transformer. Then we got the bonding jumpers. We're going to look at the bonding jumper size. Did he even run the right size ground? So I don't have the whole picture here. I can't film on site. All I've got is a picture. I might have another picture of what he was trying to feed, and we're going to talk about why that was wrong. But for this to work, I'm going to have to kind of draw this slightly a little bit here. So we can just kind of put like a whiteboard up here. Also, pay attention to that sticker. It says here, for field connections, use wire rated a minimum 90 degree C and sized on the 75 degree C ampacity. Use connector lugs marked AL9CU. Keep all wires below arrows. They keep all wires below the arrows. I went and looked at one of these the other day, and there was a hole punched right in this sticker. And I was like, "Hey man, what does that sticker say?" And he was like, "Ah, crap." So it's pretty funny. You never know what you're gonna find. Is the audio good? Can you guys hear? Could you guys hear or not? Because I just realized this saying audio is fine. Okay, because it can be better. This was actually plugged in, so I'm very fortunate that the audio even worked. Having a USB plugged in. My bad. Why is it not turning on? That might be a question for another day. I just dropped this, so maybe I broke it. It doesn't matter. Audio's good. Okay, so let's get the whiteboard in here. That is going to bug me though for a second. We hear you. Yeah, appreciate it. That is strange. Let me see here. The audio can be a lot better, so. Let's try that. Okay. Audio's got to be better now. Cheap Chinese crap. The DJI stuff is legit, man. You can hear the audio difference now. I know you can. It's good stuff. Also, we picked this. So we're going to be maybe trying that thing out. I've got this one, but it's not near as good. Let's whiteboard this. Oh no, I hit it. No, I didn't mean to hide your comment. I'm pinning it. There you go. There you go. All right, so this is what we're gonna do. We're gonna have to grab our tool. We're just gonna whiteboard this section here, right there. There you go. Okay. Hit the like button. Absolutely. Double tap the screen. Double tap the screen. It's free. And this isn't common knowledge. This is years of experience talking here. Okay, this is our transformer. We're going to have a disconnect or panel, and we're going to have something that the transformer is feeding. Basically, this box right here is what we're looking at here. Now, there's a lot of things that go into sizing this. So, first off, we need to know how many amps we're coming in with and how many amps we're trying to leave with. And when we're talking about transformers, we got primary and secondary. So we talked about that before a lot of people got in here. Black, red, and blue is going to be the secondary. The primary in this case is going to be brown, orange, and yellow, because we're going to feed the transformer with the high voltage. So we're going to have a line here. And on the primary side of our transformer, we are going to have 3 times 500. Oh, that's fantastic. Look at that. That's very nice of it. And now it's going to pretend like we didn't. There we go. Okay. 3 times 500. KC mil. And we're going to have one number something ground. Okay. So we're going to figure out what size ground we need. I don't know off the top of my head. I would probably guess in number 3. And over here, I'm showing you what they had. And then we're going to determine if they messed up or not. Then over here, they had 2 times, they had 2 sets of 500. And 2 times, and we'll do the ground size. I can't remember exactly what ground size they were, but we're going to put that here in a second. This was a 400 amp disconnect over here. Sometimes I wish I used a different program. That's okay. This is a 208 120/208. And it's a 277/240. 480, sorry. 480. Move it. Just move it. Why is it asking? Don't change my paint around. Just keep paint really dumb and stupid. And let me worry about all the AI removing background paint. There we go. Okay. And then they were going for 800 amps here. So we'll do one more here, 800 amps. And we can attempt to draw this so people walking in will know what this is. This is a transformer. We should probably just double line that ourselves. And I think they had it at a 300 kVA, which is undersized actually. But that's okay. All right, there we go. What's up, Danny? What's up, Juan? Ladder found out. It's just your step ladder. Get out of here. Step down transformer, 3 AWG, yes, for 400 typically. Saying high voltage is bad practice. It's higher voltage, not high voltage. That's true. Thank you. Okay, here we go. I probably need to go get a code book. I kind of want to look up, I have some downloads here. Sayer has sent me a code book before. So we're going to be Googling, not really Googling, but searching. So we're going to do NEC here. And I know Sayer has been begging me to use his code book. Whoa. That's not going to work. Hang on. Hang on a second. I don't want to show you my whole screen here. Which email did you send it to, Sayer? Oh, you've commented too many times on my stuff. Let's see if we can find it here. Sayer. Let's see here. NEC? Did you call it NEC? There it is. We're going to look at the 2023. There it is. Page by page. Oh my God. I can actually navigate this way, believe it or not. So we can do that. How do we go to pages? I'm so old school, guys. Oh, is that it right there? Oh, yes. Okay. So the first thing we're going to do, we're going to go to 310.16 here. Let's see if we can find it. 250. We also need the 250s, but we're going to go to 310 here. There was not a problem loading this page. Come on, Sarah, you didn't give me a whole book. Three. $310. That's getting old. Why? Why? Why is it not the whole code book? Hang on. Let's just do the... Did you delete it from OneDrive? Did you delete it from OneDrive, Sayer? We have to reload it, download it, maybe. We'll go to 17. It's all the same thing. It's all the same thing to me, guys. There's 310. Because I can edit this out whenever I need to. Okay, there's the 250.102C1. That's our jumpers we're gonna need. This is fine, we're good. And I can just scroll through here like this. Like I'm turning pages. That's 300.5. 310.15. One more. Okay, here we go. All right, so just like all the rules apply, you're going to go off the terminations. So if we have 400 amps, what size wire you think is going to work for 400 amps there if we're looking in the copper? We're going off the 75° C column. So we can go to the next standard size. I'm going to show you why. 500 at 380 here. We can go to another chapter. I got to look at all this stuff whenever I do an inspection. The OCPD was 400. We sized that already. So we had 400 amps there. So we're going to leave the 400 amp breaker. This is going to determine what size wire we can use. Go back to here. There's a couple of places we need to go. So if we go here to 240.6, what was it, kVA 300? So if we go 240.6 here, we're going to get all the standard sizes. .6 here is all the standard sizes. Here's all your standard size breakers. 240.6. You see here, 400 is the standard size and 350 is the standard size. So we're in between. We're going for copper. We could size it for aluminum later. All these other guys do, man. They know what we're looking at. I think the primary voltage plus secondary times the amps divided by 1,000 times 1.15 is the starting. Is starting a motor every 3 hours. So let's look at the rules of this. We're going to look at. We're going to look at a couple of things. We got to look at the overcurrent devices rated 100 amps or less. And it says here, the next higher standard overcurrent device above the ampacity of the conductors being protected shall be permitted to be used. So if you read all this, what it's saying is we can go to the next standard size. Our wire is good for 380 amps. We're in between 350 and we're in between 400. We're under 400. So 380 amps, that's going to give us what we just looked at. 310.15 was the 500s. And if you want to look at aluminum, we can size it for aluminum. Let's go to and this is the way I always check my charts, because I'm always out and about in the field. And if I Google the chart that I think I'm looking for, the way I find it, usually it still says formally, because first of all, it's an old picture. So I know that that's the one that I find. But also I go to 500 and my 500 is 380 and my 600 is 420. That's one way that I quickly know on the 75 C column that I'm in the right page, because you can go down here and go to the wrong one and you'll see here where 500 is good for 620, and you know that's definitely not right. And you can go to this one and see that 500 is good for 580 or 469. You know that's not right. So that's one quick way that I look, because they have changed the name of 310.15 to 310.16 back to 310.15. I think it's 310.16 like it should be. See how it says formally? It's back to 310.16 now. But they made it 15. Anyway, it's getting confusing. If we go to aluminum here, we go to, we're going for let's see here. Well, that just doesn't seem like a good idea, does it? We'd probably parallel aluminum. You probably wind up doing 2 sets of 4/0 to get to get 360, because 350 is the standard size. Yeah, because it's the 75 C column. So you could do 2 sets of 4/0 for aluminum. because you got in between 350 and 400. Look up and say hello. What's up, Rodney? Shouldn't it be 500 amps? I don't know. Let me see. Why would it be 500 amps? $100K. Oh yeah. If you're trying to size the transformer, don't try to do that. I mentioned that it was undersized anyway. The most that it can put out is it's well under 800 amps. What's your load calculation? We didn't do one. We just threw a transformer on there, and I'm showing you what they had. So let me go back to my email, and I'll show you a little bit about the transformer here. Nope, not that one. Not that one. We want to go to... I don't want you to think I'm ignoring you, but you're slowing things down here. I don't have the cover of it. I don't have the cover of it. Nope, no cover. There's a 300 kVA though, which is undersized. Yeah, you multiply by 1.732 for 3-phase. So they have 3 times 500s. Now we got to look at the ground. So now we got to go to 250.66. And yeah, I gotta look at all of these codes for every individual wire, every individual set, every individual run. 250.66 is when you are not with overcurrent protection. So we want 250.122 because we're coming off of a breaker. So we have overcurrent protection. And we're going to use the number 3 for 400 amps. Or we're going to use the number 1 for aluminum. So let's go back here. This would be number 3. That's not going to work. Cool. Now, we have flex here. And we got to look at the rules of flex. No flooding in my area, man. It was okay. Appreciate it, Rodney. We got David. They're still trying to do a load calculation, which I'm not worried about right now. But we could if we wanted to. We would you'd take the amperage times 1.732 divided by the voltage, and let's see. So you'd have... We'll do that here in a second. Let's look at the flex rules, because we have a raceway from here to here. And what we know about transformers is that we have to have flex for the vibration of transformers. You never really pipe to a transformer. So let's look at the rules of flex. Now, we got to look at why we're going to have a bonding bushing. So let's look back at the picture. What did they do? It looks like they put a bonding bushing. Did they have to put a bonding bushing if they ran flex? Let's find out. First off, it's 480. Next off, It looks like they probably knocked out the whole hole. Right, he knocked out the whole hole there. So he's on a concentric knockout. He's 480 volts. Let's see what the code says. For that, we're going to go to, good Lord, let me think about this. We are going to go to 3. No, we're going to go 250.118. Let's go 250.118. Because the 300 is going to take us to 250.118. So let's see what 250.118 says. Okay. Types of equipment grounding conductors. Okay, so we're going to break this down here in a second, but there's a couple of rules here. The equipment grounding conductor run with or enclosing the circuit conductor shall be one or more a combination of the following. So we've got copper, aluminum, copper-clad aluminum conductor. This shall be solid stranded, insulated, covered, or bared in the form of a wire or bus bar or any shape. Okay. You've also got rigid metal conduit. So rigid metal conduit is considered an equipment ground. You got IMC, you got EMT, and it says you got listed flexible metal conduit meeting all of the following conditions. So it says here the conduit is terminated in listed fittings, which it probably is. The circuit conductors contained in the conduit are protected by overcurrent devices rated at 20 amps or less. Well, that's a 400 amp breaker. Then you got to be smaller than 1.25 inches. And then the combined length can't be more than 6 feet. Now, if it's used to connect equipment where flexibility is necessary to minimize transmission of vibration from the equipment that requires movement, just like a transformer, an equipment grounding conductor shall be installed. So, what they've done here is they have installed a ground in here because we knew that we could not use the flex as a conductor, as a equipment ground, because we just saw 1, you couldn't be over 1.25 inches. 2, you couldn't be over 20 amps. 3, he is using listed fittings, right? And then he probably wasn't less than 6, but you got to be all of them. So did he have to put a bonding bushing on here? Did we have to make sure that that flex was bonded? It really depends on how everything got connected. But because it's 480, we're going to look at the rules of 480 now. So let's look at what the code says about being over 250 volts to ground. Because we're over 250 volts to ground. So if we go to 250.97, thank God I know all these codes off the top of my head. 250.97. What does it say? Bonding over 250 volts to ground. Okay, so for circuits that are over 250 volts to ground, which we are, the EMT of metal raceways and cables with metal sheaths that contain any conductor other than the service conductor shall be insured by one of the methods. And what it says here is that we're going to use listed fittings. Fittings with shoulders of C, 2 lock nuts, blah, 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 blah. But these codes coincide with each other because this code says that your raceway itself has to be suitable for a ground in order to do all this. And obviously the raceway is not, because it's over 6 feet, over 1.25 inches, over 20 amps, but we did use listed fittings. So when you look at whether or not you do have to bond, remember that we're over 250 volts to ground. So we have to bond our raceway. The electrical continuity of metal raceways and cables, right? So we have to make our raceways electrically conductive. Continuity. So yes, we do have to use the bonding bushing because we're using flex that's not considered an equipment ground. So what they did here, they ran flex. I can't tell what's going on with my chat right now. Okay. So yeah, we bonded the flex. Done. And we used the number 3. So we're good here. Then we took our conductors and we landed on the transformer. We're protected with 400 amps. And our wire was suitable. Okay. Now we're going to look at grounding electrodes. So when we look at grounding electrodes, let's not look at grounding electrodes first. Let's look at the other conductors. Let's look at the secondaries now. We're going for 800 amps. Okay. These guys ran 2 sets of 500. And that's wrong. I'm going to tell you why it's wrong right now. So 2 sets of 500, we know, is good at 380 amps each. And if you multiply 380 by 2, you don't get 800. So let's look at why these conductors have to be 800 amps of wire and these conductors don't. Looks phased out to 208, not 408. Oh, I got you. Yeah. Sorry, man. All right, so why do the secondary conductors have to be exactly 800 amps and these conductors don't? We used 3 sets of 500 and these were at 380. So we'll just put an at 380. Okay. 2 sets of 500 at 380 is less than 800. Let's look at why we have to do that. So we're going to go down here, back to our code book. Whew, where is that? That is in 310.21. 310.21. Let's look. That's 2. $230, $240. Might be in 240. I think it's 310.21. I saw the word tap. Where'd it go? $310. Is it in 240? It's 240.21. It's not 310.21. That's stupid. It's 3. What the hell is it? 240. 240.21. There it is. Okay. There. All right. So we have taps. We have primary overcurrent protection. We have transformer secondary conductors. Right? We've got more taps. We've got secondary conductors not over 25 foot long. Secondary conductors. So when we're dealing with transformers, we don't have taps. We have what we call secondary conductors. So let's look at what the code says about secondary conductors. We got to be, all these rules says all the following right here. The ampacity of the circuit conductor is not less than the combined calculated load on the circuit. That makes sense. So in not lawyer talk, what it means is if you need 700 amps, you better have 700 amps of wire. Okay. Not less than the rating of the equipment containing an overcurrent device supplied by the secondary conductors, or not less than the rating of the overcurrent protective device at the termination of the secondary conductors. Okay, so in this case, if we're landing this on a 800 amp breaker, this is the electrician channel. I'm an electrical inspector. I do a lot of tools and reviews about what works for electricians, but we really dig into common mistakes and things to help you guys out. And right now we're sizing every conductor, the whys and why you can, and breaking this down on a microscopic level of how to do every wire in this transformer, basically, and what you can and can't do. Okay. Let me pull up another page here. Let me open up another paint, because I will show you what they were landing on. Okay, here's our breaker here. That's an 800 amp breaker. I don't want to show you guys the job name because you guys can look that up. If you're ever curious about where a piece of equipment come from, I could call Square D, I could look up this job name, and they'll tell me exactly where this came from. What job, everything you want to know about it, the address, everything. Just so you know. Think twice before you start taking pictures of what you guys do. Okay, so we're landing on 800 amps. Okay, we do have that rule in 240.6 that says $800 amps or less. 800 amps or less. The next higher standard rating does not exceed 800 amps, right? This is the most common mistake that I see in the field right now. The next higher standard rating selected does not exceed 800 amps. So when we go to the standard ratings and we go to 240.6 and we see that if we've got at least 700 amps of wire, we can go to the next standard size. And then we go back to what we ran, and we see here they ran 2 sets of 500 at 380 each. So yeah, they should have at least 700 amps of wire. Why do I need 800 amps of wire? This is why. Right there. The rating of the overcurrent protecting device at the termination. The ampacity of the conductor. That's tap, sorry. We gotta find. There you go. Transformer, secondary conductors. The ampacity of the conductor is not less than the rating of the overcurrent device at the termination. So this is why you have to be equal or more on the secondary side of a transformer, whether you like it or not. It's the most common mistake that I see, and everybody loses their ass, literally. You lose money if you don't know this rule. So we can't use 500 if we're doing copper. We're going to have to go to 310.16 or 15, depending on what freaking book you're in. Right here. And you're going to see that we need at least 600 at 420 amps each. 2 sets of 600 kc mil. So in this case, we need 2 sets of 600. Make sure it's black. There we go. Okay, so we need 2 sets of 600. Now, what size ground is that? This one's kind of tricky because the wire is coming from the transformer. This is almost like a service. We don't have overcurrent protection to size these wires off of. If we were feeding the transformer with 800 amps, we could say, yeah, we need 800 amps of a ground wire to go backwards. But so let's see what that is. We're going to go with 2 sets. So if we look down here, we got 2 sets coming in. What size ground needs to be here? How are we going to size this ground? We're going to size that ground like this. We're going to go to 250.102C1. And what we're going to do, because we don't have overcurrent protection to size our grounds off of, we're going to size it off of, I wish it would tell me here. Let me see if I can find it for you. The bonding jumper, let's see here. Let me go to 250.66 so you guys can understand what's going on right here. And what it says here is we're going to be sizing our ground wire based on a service off of the largest ungrounded service entrance conductor. See that right there? So we're not sizing this ground wire off of amperage. There is no amperage chart here. What we're looking at is the total KC mil. So in this case, we have 2 sets of 600. So we see here, if we have copper, 2 sets of 600 through 1100 KC mil. Well, we have 1200 KC mil. So that's going to be a 3/0. Or we have individual 600s, and that's going to be a 1/0 to each pipe. So let's see what that looks like. In this case, they have 2 pipes, so they can do a 1/0 to each bonding bushing. It's not a grounding electrode. It's not a GEC. It's did I not go to 250.102? Yes. Hang on. Let me fix that. We went there to explain that, but I never went back to 102. There we go. Okay. Same thing. It's the same size. So you're right. Grounding conductor, main bonding jumper, system bonding jumper, supply side bonding jumper for AC systems right here. All right. Same thing. So we're going to see here 600 through 1100 KC mil is, we're at 1200 KC mil. So we need a 3/0 pretty much for both of those. Or we can do a 1/0 individually. Is that better? Appreciate it, David. Okay, so now we're going to go over here and we're going to look at what they did. Just like on this side, we got the bonding bushing here. We sure as crap need a bonding bushing here. We're not over 250 volts to ground. So you say, why do I need a bonding bushing if I'm not over 250 volts to ground? Well, this is considered a service. Similar. It's secondary conductors. There is no overcurrent protection here. So I'm going to show you why you need to have a bonding bushing and why this all needs to be bonded, why this has to be the way it is. So let's look at a couple of codes. First off, I just want to point out that we could do, and this is what they did, I think they had an individual run the bonding bushing to each one, because if you see the 2 wires coming here, you have one for this bonding bushing, and you had another one for the other bonding bushing there. So we ran 2 1/0 over each one, or we could run one single 3/0. We could run one large we can hit both bonding bushings. You got a problem with my voice? I'm clipping. I'm just going to unplug it. We're just going to unplug it. Appreciate it. Okay, you guys hear me now. Appreciate it, Rich. All right, so let me unpin this one. I don't know what to pin. That's been driving me crazy. Okay, so we can do 1 3/0 to both of these, or we can do an individual 1/0 to each one. Now, this comment, like, why will it not go away? This comment will not disappear. What's the Professor Oak? Okay, let's go back to. You can't read the squiggles. The squiggles is a bonding jumper. The squiggles is a, where the heck is my mouse? The squiggles is a, let's go back up here. So in this case, 2 pipes there, 2 pipes, right? We can do an individual 1/0 here and there for the bonding bushings. Okay. Or we can do 1 large 3/0. I've lost my mouse again. We do 1 large 3/0. Hit this lug, bear the copper, and then hit this lug. And then this would be a 3/0. He's running Farsi. Good one, George. Okay. So let's look at a couple of reasons why we have to bond. We're going to be going to, what is it, 292. Can anyone see that comment, or is it just me? Code's battery level is high. 69. Why you guys can't hear me? Robocop. Apparently, you guys can't hear me. Let me do this. This is Rich. Okay. That's got to be better. Sound sucks. Appreciate it, tools. Big Josh. I bet the audio is better now. It got better. Yeah, this is YouTube for us. Thanks. I guess I'll explain that part again. Thanks, YouTube. Okay, so we can do 1 individual 3/0, or we can do 2 individual 1/0s based on what I just showed you guys for the bonding bushing. Now, why do we need a bonding bushing? Let's go to 250.92. Right here. 98, 97. All right, methods of bonding of the service. Bonding jumpers meeting the requirements of this article shall be used around impaired connections such as reducing washers, oversized eccentric standard lock nuts, and bushings shall not be the only means for bonding required. making this section, but shall be permitted to be installed. The heading of this code here is bonding for services. So the normally non-carrying and carrying metal parts of equipment indicated in 250.92A1 and 2 shall be bonded together. And transformers are basically a service. You don't have overcurrent protection. You're creating a new voltage. There is no way to there's no overcurrent protection. So when we look at the secondary side of a transformer, one, it definitely has to have overcurrent protection, typically. And then two, we got to bond the raceways. So this is why don't you think a transformer is a service? It's a secondary conductor. It's basically the same thing. I'm not saying it is a service. Okay. Next. So we've got, where'd the mouse go? Here we go. Let's do that. We had 2 times 1 aughts for the ground. Soberly dry system. Yeah, it's creating a voltage. It's got to have overcurrent protection. The raceway has to be bonded. All right, so now we got to look at what size jumper we need for XL, because we need to bond the grounds back to the neutral. So it's pretty much the same thing that we just saw. If we go to 250.102C1 here, we've got 1200 kc mil. So what we're going to do, we're going to take the ungrounded supply conductors that's larger than 1100 kc mil. We're going to take 12.5% of that. But basically, we can run a 3/0 to it for sizing this. My kids are home, so we got to hurry up. This is fun. You love this content. Appreciate it, Tony. Yeah. Hey, when did somebody send me $2? Was that you, Josh? Why is YouTube so terrible about... I'm scrolling up. Whoever sent $2, man, I appreciate you guys supporting the stream. This is too complicated. You're going Amish. Okay, so we have a 3/0 for the main bonding jumper. Right there, main bonding jumper. Or actually, I take that back. In this case, this would be the SBJ. This would be the system bonding jumper. SBJ, right there. So if we look at the definition of a system bonding jumper, we're going to see here. Look in definitions here. And you guys would be surprised how useful the definitions are when it comes to the test. So it's probably in bonding, and then it has all the jumpers. So if we look at bonding, it has all the jumpers. Here we go. And what we're going to see for the system bonding jumper, which is somewhere here. Bonding system, connection between the grounded circuit conductor and the supply side bonding jumper, or the equipment grounding conductor, or both, at a separately derived system. So that is the definition. That's why I corrected myself really quick. This is, by definition, the transformer. So the correct term here is the system bonding jumper. And when we look at 250.102C1, we're sizing transformers. There's no specific question. It's all the questions. There we go right there. And we got system bonding jumper right there. So that's how you size that. Okay. We just had to refresh this now. That DeWalt bandsaw tactics got it 2 weeks ago. No, the DeWalt bandsaw that I got was a 12 volt. You're talking about the 20 volt, I believe, which is probably better, but not as compact. Still a great deal, but not as compact. If you're going for the most compact thing, you want the 12 volt, just because you just don't need that much power or capacity, especially if you're just running 3/4 pipe. Okay, what's next here? Yeah, we could size the cold water the same way. You could size all that stuff the same way. I'll show you guys an interesting code here. See how this is a common bus here? They eliminated the permission for you guys to install multiple lugs. So if we look at the code here, we have to have one common terminal bus to land all these grounds to. We can't have a whole bunch of individual lugs nowadays. Yes, with the power stack, the atomic inch and a quarter. Yep, 18 volt. Okay, so let's see here. What is my mouse doing? It's gone. Had to find it. If we look in grounding, let's see if I can find it in here. Let's see if I can find it here. Separate. It's going to be. It's going to be in one of these areas here where it talks about all this stuff. 166. That's getting more into we gotta go back up here. Yeah, there's a new, oh, you know what? We're in the 17 code. We're not going to find it. It's not in the 17 code. I don't think we're going to find the code that I'm looking for, because it was not a code. Yeah, but it's here somewhere in the new code. Yeah, there's no point looking for it in this code because it doesn't exist. What time are you doing these codebook questions? I don't know. Whenever I get time, I just jump on here and just do. We're just sizing a transformer tonight. All the wires for it. Let's see how far we got here. Usually like 7 o'clock. 7 o'clock. Tuesdays and Thursdays. Alright, so we had 400 amps. 400 amps here. That was the overcurrent protection. We sized it with a 500 kc mil. It was good for 380 amps. We're allowed to go to the next standard size because we weren't a service, we weren't a secondary conductor, and we fell in between 350 and 400 amps. Then we went to 250.122, sized the ground wire based on the overcurrent device, which is a number 3, and we ran a number 3 across. Then when we got inside the transformer, also we were 480 volts to ground, or we were 250 volts to ground, 480. So we did a bonding bushing there. Then we come over here. Even though we're low voltage, we were secondary conductors. So we had to use a bonding bushing. And we could do a 1/0 to each one, or we could do a 3/0 to daisy chain them. Then because we were a secondary conductor, we had to be equal or more, which is like the most common mistake that everybody makes. Let me see here. How many curling irons, straightening irons to blow, and blow dryers can be used in a strip club dressing room? Ah, that's pretty good. Okay. Yeah. So 2 sets of 600, good for 420 amps each, gives a total of 840 amps. And then we were good there with our grounds. And then pretty much a 3/0 based on the kc mil here to the cold water, because we're a 1200 kc mil. So if we were to bond either place, if we bonded at the first means of disconnect or we bonded in the transformer, we needed a 3/0 to the cold water, building steel, something like that. But this is what size is the transformer? This one here was a 300 kVA, which is tiny, because you're not even going to get the amount of amperage of 800 out of it. It's impossible. This transformer needed to be like a freaking at least 500 kVA, I think. But this was temporary. That's why it's sitting on a pallet outside. All right, so let's size the transformer. Hang on. I need to get my calculator out for that. Let me grab my other phone here. I use my work phone. There's a long password. Okay. You know what? I don't bring my phone up. What if somebody calls me? Let's just do calculator here. Let's do that. Okay. So we're going to do the voltage by the current by 1.732, and then divide it by 1,000, I think, because that's the kVA. So it'd be 208 times 1.732 voltage times current times 800 equals, and then we're going to divide that by 1,000. Is that right? Well, that is a 228 kVA. Is that right? Temporary power, anything goes, yeah. Exactly. That doesn't seem right. That doesn't seem right. Let's do this. 208 times 1.732 equals 360. Yeah, 360. Yeah, so it's 360 divided by, we can do it backwards, I guess. I guess I could just have to do it backwards. 500. Sorry. Oh, that's not the delete button. Oh, 500 is good for 1200 amps. What is that calculation? I might have to look it up. I thought you multiplied the voltage by the current. And then by 1.732. And then you divide by 1,000. Calculating the kVA of a transformer. Let me try this in my head here, without three phase, or something. Let me see here. So if we did, if we had 240 volts, let's say we had a 240 volt load at 150, 200. Let's go 175. We'll go 175. We're going to divide that by 1,000. And that should be close to 42. 42 exactly, yeah. So you'd do a 50 kVA transformer for this. So if we reverse engineer that, and we wanted an 800 amp load, we would do 800 times, no, we would do, the voltage is 208. But it's three phase. 208 times 1.732 equals 360, right? Times 800. Times 800. And you divide that by 1,000. Oh, I guess 300 kVA is right. Yeah, this would be a 300 kVA transformer for an 800 amp load. How do you suddenly know the amperage at Makita headquarters anyway? Power in and out. If you know the primary numbers, you can calculate the secondary and lower voltage to raise the current. Oh, what's up, John? $166 kVA. If we had a 400 amp panel, a 240, we would do 240 times 400. And then we would divide that by 1,000, and that should give us a kVA. It'd be a 100 kVA transformer. Yeah. Yeah, so I think that would be a 300 kVA transformer actually for 800 amp load. Yeah, all day. That's actually that should be right. All right, let's get this thing open. Sorry, my daughter's loud. Oh, we bought a new bed last night. We bought a, you can't even see it. We bought a Simmons Beauty Rest, black. It's an ultra plush. That's not working. Oh, look at that. They already had it ready to go. I don't like the look of that. Why is that? Silicone strip light. I guess there's a light at the base. Oh yeah, we got the silver one too. Oh, the strip light goes in here, so that's an interesting way to make us do that. This thing has too many pieces to do this live. I understand that it's common practice to run multiple of 12 gauge wire in commercial applications, but why? Because of this. Uh, 310. We go here. This one, right? Right there. Okay. Adjustment factors for more than 3 current carrying conductors. Okay. So when we look at the rules here, and I'm going to do my hardest to find these rules. Let me see if I can find it. What it's going to say is that we can use the 90° C column, but I don't know where it's going to say that. More than 3 current carrying conductors. Where the number of current carrying conductors in a raceway or cable exceeds 3, or where single conductors or multi-conductor are installed without maintaining spacing. Table 315 B3A, each current carrying conductor at a parallel set of conductors shall be counted as a current carrying conductor. We got to find the rules here. Where we can use the 90° C. I'm not familiar with this code book exactly. But there's a factor in here that says we can use the 90° C. I would like to find it for you. Neutral. Ground. Does anybody know where it is? It usually says it right on here. Oh, a minimum of number 12. Oh. Oh, where's that rule? That rule is, that is a very good question. Let's look in general definitions. Is my kid loud, guys? Let's look in the requirements for general installations. Voltages, conductors, wiring methods. I don't know exactly where that code is, but I'd like to find it. Field marketing. That'd be a good AI question. Outdoor transformers. It would be in here. AI doesn't know anything. It gives you the wrong answers left or right. Let me see here. Where does it talk about anything less than switchboard switch? It's got to be in here somewhere. We could look in branch circuits as well. We could go to 220. We'll try that here in a second. We're back in definitions. I wasn't paying attention. Scope, approval. I'm just scrolling through here very quickly. Here's the terminals here. Conductors, terminations for circuits rated over 100 amps. This is where I thought that I would find it. Let's go to 220. Hit the switch when the screaming stops. Yeah. Let me see here. Let's look at that's identification. There's branch circuits. Okay. Yeah, that's just one of those codes that you just do. I don't actually know exactly where it says in the code that you don't use. That's the number 12. Other than dwelling units, maybe here. That's GFCI. That's not it. Therefore, I'm not seeing it. Ask my boss tomorrow. Like, where is that in the code? Why are we calling this? Oh, it could be in 240. It could be in 240. Feeders. Let's go to 240. Your daughter wants dessert. Are you sure? Let me see here. Yeah, my wife is too patient with her. All right, let's go to, that's outside branch circuits. Let's go to we're not going to go to services either. We're just going to go straight to 240. Okay. Fixture wire, ampacities. Here it is. Let's see if we can find it here. Hang on. Okay, beginning. Definitions, tap, other articles, protection. No, I don't know where it is, man. We tried. We tried. That's a good question. I enjoyed looking that one up, but I did not find it. Yeah. Nope, not here. What's up, Owen? All right, well, I think my daughter wants dessert. Sounds like she's not gonna get it. What is the continuous amperage rating of a EC5 connector? Is it a 120 amp or a 60 AL? AI. What is the continuous amperage rating of a EC5? What is an EC5 connector? I've never thought to myself, damn, I would like to buy an EC5 connector. It'll be on the installation instructions. It'll be on the installation instructions, like there's a dude on YouTube. All right, we're gonna get. We'll see you guys later. We're out of here. Better search engine than Google. Appreciate it. We're out of here.